So we're told that g of x is equal to 2x minus 1 over x plus 3. Based on this, pause the video and see if you can figure out what the inverse of g is. G inverse of x. What is that going to be equal to? All right, I'm assuming you've had a go at it. And just as a little bit of a reminder of what we're talking about when we're talking about inverse of functions or inverses of functions, if that's the domain, the set of all inputs that we can input into g, so that's the domain. And if we consider the range to be the set of outputs, so that is the range, for a given input, so for a member of the domain x, the function g, let me do it in that color, the function g will map it to a point, let me do g in yellow. It will map it to a member of the range. So if this is x, this value right over here we would consider to be g of x. That's what the function g does. Now, the inverse function goes the other way. You start with a member of the range and you go back to a member of the domain. That's what g inverse does. And so there's a couple of ways to think about it. If we were to say, look, let's just set y is equal to g of x. So we could just call that point y as well. So this says, this expression here lets us know, okay, if we have an x, this is what we do. We multiply 2 times it, we subtract 1 divided by x plus 3, and then that tells us what the associated g of x or what the associated y is. But what if we're given the y or the g of x? How do we get x? Well, we could just solve for x. So let's do that. If we said that y is equal to 2x minus 1 over x plus 3, let's solve for x so that we know that for any y we get, what x the corresponding x will get. So how do we do that? Well, we can multiply both sides times x plus 3. So if we do that, we're going to get y. We're going to get y times x plus 3. X plus 3 is equal to 2x minus 1. All I did is multiplied both sides times x plus 3. X plus 3, and I multiplied x plus 3 on that side as well. The x plus 3 cancels out with the x plus 3. And then let's see what we could do now. Well, we could distribute the y. And I'll switch now to a different color because that's going to get complicated if I keep trying to separate the y's in a different color. So we're going to get y times x, yx plus 3y is equal to 2x minus 1. And remember, we are now trying to solve for x. So we could collect all of the x terms on one side of this equation, and then all of the non-x involved terms on the other side. So let's get all of our x terms on the left-hand side and all of our non-x terms on the right-hand side. So I want to get rid of this. This doesn't involve an x, so let me subtract 3y here. And so I'll subtract 3y from this side, minus 3y. And we want to get rid of this from the right-hand side, so minus 2x. So we could put it right over here, minus 2x. And so we are going to get, let me scroll down a little bit. So, whoops, sorry for that. So this is going to be yx minus 2x is going to be y minus 2 times x. These cancel out, which is their goal, is equal to 2x minus 2x, those cancel out, which was the goal, and then you have 1 minus 3y. 1 minus 3y. And now to solve for x, you just divide both sides by y minus 2. Y minus 2. And we're going to get x is equal to 1 minus 3y over y minus 2. So one way you could think about it is you could say, well, x is equal to, this expression is equal to the inverse function as a function of y. You give me a y that's sitting in this range. I can input it into this function definition here, and I can give you the corresponding x. Now, we didn't ask for g inverse of y. We asked for g inverse of x. But the important thing to remember is this variable that we use inside of functions right over here. They're chosen somewhat arbitrarily. They just say, okay, I'm going to call the input y, and if you're going to call the input y, well, this is how I would give you the output. But we could call the input a, and that would be 1 minus 3a over a minus 2. Or we could even call the input So let me make this clear. So we have G inverse of y. Actually, since I did it in blue up here, let me write that in blue as well. So if we did G inverse of y, I'm just rewriting what we already have, is equal to 1 minus 3y over y minus 2. This choice of variable is arbitrary. We could say G inverse of smiley face is equal to 1 minus 3 times smiley face, over smiley face minus 2. Or if we wanted in terms of, if we want to call the input x, we would just write G inverse of x is equal to 1 minus 3x over x minus 2. And we'd be done. Now I really want to point out, you might say, well, this is confusing because now we're calling the input to this x, while we normally associate y with the variables in the range. That's true, but you have to remember these variables, they're just labels that we apply to things so that we can keep track of them. But they're just what we call the input. So we could call the input into the inverse function. We could call it x, smiley face, y, a, b, c, d, whatever we want. So they want it in terms of G inverse of x. So we're going to define the input as x, whatever we input into it as x. And so this is going to be the expression that maps back. Now another way that you could have done this, because if you think about what just happened here, if we said now that y is equal to G inverse, we've essentially swapped the x and y variables. So one way to solve these is you can start where we started, right over there, and then you swap the x's and the y's, which is essentially what we did at the last step, the way I did it, and then you solve for y after the swap, and you would get to this same result, and you could say y is equal to G inverse. So I encourage you to try either way.